Hello, geometry students. In this lesson, we are going to be finding the perimeters and areas of composite figures. What is a composite figure? A composite figure is a figure that's made up of more than one part. It could be more than one rectangle or other quadrilaterals. It could be part rectangle, part circle. Could have triangles in it. Sometimes it's a bunch of figures plastered together, and sometimes it's a figure that looks like Swiss cheese because lots of other figures have been removed from it. So we're going to have to use our heads to figure out what the areas of these figures are. There are two postulates that we need to keep in mind in this lesson. Both of them are pretty obvious. The first one, if two polygons are congruent, then they have the same area. Well, duh. That one's pretty easy to visualize, right? If two polygons are exactly the same, their area also is the same. And then postulate 20, if you add the areas of a bunch of polygons in a composite figure together, as long as each area is only represented once and the entire area is accounted for, okay? So we don't have any overlapping parts. And also, I'm just going to add, we're not excluding any parts. If we add together the areas of each part, we get the area of the whole. And I just want to point out, this also works with subtraction. If I have a big figure with a little piece missing, I can add the opposite of that piece or subtract that piece, and I will end up with the area of the whole part. So it's important to realize what we're doing here. The very first thing you should always ask yourself when working a problem is, am I adding areas or am I finding an area and then subtracting areas? Make sure you think about how the problem is set up. I think in these ones, we're going to be adding areas, but in some of the lesson problems, you are actually going to be subtracting areas. There's some that look like maybe you can add the areas, but actually in the end, it turns out to be way easier to subtract areas. And you'll know that if you have like a big rectangle and there's pieces of the rectangle missing and those pieces don't line up perfectly, that's when it's probably easier to subtract the pieces that are missing instead of trying to add the smaller rectangles together. You'll see what I'm talking about in future practice problems, but let's go ahead and see if we can figure out these practice problems. Letter A, composite figure is made up of a rectangle and a triangle. It has a 3-inch horizontal side, two 4.5-inch vertical sides, and two 4-inch sloping sides. What is a perimeter? Wow, this would be way easier if there was a diagram. I'm going to recommend that we make a diagram that shows what's happening. Okay, so it's a rectangle and a triangle with a 3-inch horizontal side, two 4-inch vertical sides. So that's going to look like this, where I have this horizontal side at the bottom and then two 4.5-inch vertical sides. And then I have sloping sides at the top. So I'm going to go ahead and we'll just put a triangle on top of this. It's going to look something like this. And if I don't get things lined up perfectly, it doesn't really matter. But this is basically what it looks like, okay? So if I were to put labels on this stuff, I would have 4.5 here, 4.5 on the other side. I only have to label that once. The bottom is 3 down here. Okay. And the top is two 4-inch sloping sides. So I'm just going to put a 4 here. And we'll just, in the same box here, put a 4 over here. Perfect. All right. Now, this gives me all the information I need to find the perimeter. I just need to add up my pieces. And now that I've got it all drawn out, it's going to be really easy to do it. Here, let me just put another 4.5 over here, and I'll just add all the way around. 4 plus 4 is 8. 4.5 plus 4.5 is 9. 8 plus 9 is 17. 18, 19, 20. The perimeter of this is 20. Let's see if I'm right. 20 inches. So all I needed to do is draw the figure they were talking about, put on the sides, and then I was easily able to figure it out. Determine the area of the figure. Express your answer in terms of pi. So I'm not going to simplify pi. I'm not going to approximate pi to 3.14. I'm going to leave it as pi. All right, and this is my figure. I notice this is a square because of all the way it's marked up, 4 right angles and 4 congruent sides, square. And then I have a half circle, a semicircle. All right, so let me just keep track. Let's see, the area of the figure. Well, it's going to be 4 times 4 for the area of the square. And I need to add to that the area of the circle. I noticed that the radius of the circle, the diameter of the circle is 4. So the radius must be 2. And I know that pi times 2 squared, okay, or pi times 2 squared is just 4, is going to be the area of the circle. But wait, I don't want the area of the whole circle, pi r squared. I want pi r squared divided by 2. Well, pi times 4 divided by 2 is just pi times 2 or 2 pi. So my answer here is going to be 16 plus 2 pi. And here, let me just go ahead and grab the proper character for pi. It's easy enough to do. There we go. We'll just grab pi, and that is that. All right. It looks bold. There we go. Okay. That's letter B. So now I've gotten letter A and letter B done. Let me just double check my answer for B. 16 plus 2 pi. I did forget to put a label on. That's a great thing to do. It should be centimeters squared. There we go. All right, on to letter C. A rectangle with dimensions 3 by 1.5 centimeters is removed from the bottom left corner of this figure. So we're removing a rectangle. Determine the area of the new figure. Express your answer in terms of pi. So it's going to be 16 plus 2 pi still, okay? But then I'm subtracting, I'm removing part of my figure. And that's okay to do according to our theorem. Because remember, subtraction is really just addition of an opposite. So it fits the area addition postulate. Except now I need to subtract a rectangle with dimensions 3 by 1.5 or 4.5, right? Well, 16, I can combine 16 minus 4.5. 16 minus 4.5 is 11.5. It's still going to be plus 2 pi. 11.5 plus 2 pi, and it's still going to be centimeters squared. And let me just make sure that I've got this right here. Okay, so put our centimeter squared label at the end. And then here, let's check. 11.5 plus 2 pi centimeters squared. And all I did was I subtracted a rectangle, 3 by 1.5, from the corner here. All right, on to letter D. A new office building has one side in the shape of a right triangle on top of a rectangle. The rectangle is 420 feet tall and 120 feet wide. That's a pretty straightforward shape to find the area of. The triangle's base is 120 feet long, and its vertical leg is 160 feet long. Now, one thing I know about right triangles that I remember, now, first of all, to find the area of a triangle, we need base times height, where the height is the altitude, right? It's 1/2 the base times the altitude height of the triangle. But if this is a right triangle and I know one of the leg is the altitude of a right triangle. So that makes this super, super easy. Okay. What is the perimeter of this side of the building? Okay, so the first thing I have to do for one like this is we have to make a diagram that shows what's going on. So let's do that up here. We're going to do that, and then I need to add a right triangle. So let me grab that. We have a right triangle on top of our rectangle. Okay. And then we know the sides of our rectangle. Let's see. That's going to be overlapping a little bit. That's fine. We know that the sides of our rectangle are, let's see, 120 feet wide at the bottom. So I'm just going to 120. And then the height of this is 420 feet. So let's put that over here. 420. So I could find the area of this. And then the triangle's base is 120. Well, that matches this, so that makes sense. And the vertical leg is 160 feet. So I'm just going to put a 160 up here. All right, there's no surprises here. This is exactly how I envisioned it. So this is going to be 120 times 420 plus 120 times 160. And then I need to multiply that by 1/2 or divide it by 2. Okay. I'm just going to do the big math on the calculator tab over here. 120 times 420 plus, and then we need to do 120 times 160 divided by 2. I get a total of 60,000, and this is going to be square feet. 60,000 square feet. Let me just double check that. That seems a bit on the nose. Oh, hold on. Because I'm asked, not. I did the bottom part. Let's see. How much glass is needed to cover the side of the building? That one's going to be 60,000 square feet because I found the area first. I should read the problem more carefully. What is the perimeter of this side of the building? Well, this one's not too hard to figure out. Let's see. The perimeter is going to be the all of the different sides added together, except the only part of this that's a little bit hard is that I have this right triangle on the top. um, but that's not too bad because I can just use the Pythagorean theorem, 120 squared plus 160 squared, and take the square root of it. Let's do that. So 120 squared plus, and let's see, let me just double check, 160 squared. And I want to take the square root of that number. So let me just do that right away. 200. So I use the Pythagorean theorem to find this top side of my right triangle right here. Came out to 200 feet. Okay, so now I just add all these together. 160 plus 120 is 280. 280 plus 420 is 300. 700. 700 plus 420 is 1120, and then 1120 plus 200 is 1320. 1,320 feet, adding all of the sides together. And then I figured out, I accidentally did, okay, so D was adding all of the sides, and then E was finding the area. I accidentally found the area first because I didn't read the problem carefully. But this one's 1,320 just by adding all of these sides together. All right, I'm going to encourage you when you do the homework to read the problems carefully so you're always solving for the right things. Be resourceful. Check to see right away whether you're going to subtract things or add things, okay? And if it makes more sense to subtract, make sure you do that. And do the problem set for next time.